Hello, everybody. Welcome to Mrs. Baker's Chemistry Corner, the Monster Paper Walkthroughs. This is Module 10 Metals, and it is question 13. So this question is about electricity and chemical reactions. The electrolysis of concentrated aqueous potassium bromide using graphite electrode forms hydrogen at the cathode and bromine at the anode. The electrolyte becomes aqueous potassium hydroxide. So state what is meant by the term electrolysis. Well, electrolysis, the word, comes from electro, meaning electricity, and lysis, meaning to break down. So it is the breakdown of an ionic compound. The compound must be ionic, so you need the word ionic in there, using electricity. And as you can see, we've got our 2 bullet points there for the 2 marks. State why graphite is suitable for use as an electrode. Well, need to say that it is inert and also that it conducts electricity. So we'll say and a good conductor of electricity. You need 2 marks there because they're nice, easy marks, but there's 2 reasons why we use graphite, so you must include both. Write an ionic half equation for the formation of hydrogen at the cathode. So we know that hydrogen is going to go from hydrogen as an ion, to hydrogen gas. Therefore, we're going to need 2 hydrogen ions to balance out and make the hydrogen diatomic molecule. Now, because we've decreased in oxidation state, decrease is reduction, reduction is gain. So we must have had the 2E minus on this side of the equation, on the left-hand side, because we've added it in to the hydrogen ions to make hydrogen gas. Name the type of particle responsible for the transfer of charge in the conducting wires. Well, in wires, it's always electrons that conduct electricity. And name the type of particle responsible for the transfer of charge in the aqueous potassium bromide. Well, in the electrolyte, it's always ions. State the number of products formed when electricity passed through the dilute aqueous potassium bromide using graphite electrode. So we're now doing dilute aqueous potassium bromide, whereas before we had concentrated. Now we know if there's a concentrated halogen present that it's the halogen that will form at the cathode. But if in this case we've got a dilute substance, then it's a battle between the bromide ions and the OH minus ions from the water. Now, because it's only dilute, the OH minus ions are going to form, and we're going to end up with oxygen at the anode instead. So it will be oxygen here instead of the halide. And at the cathode, we've got potassium battling it out with hydrogen ions. Remember, the hydrogen ions come from the water as well. Well, the rule is that the least reactive will form, and using our reactivity series, we know that hydrogen is the least reactive, so we will get hydrogen gas. Bauxite is an ore containing aluminium. Aluminium is extracted by electrolysis of purified bauxite in molten cryolite using carbon electrodes. So name the aluminium compound in purified bauxite. That is, of course, aluminium oxide. State 2 reasons why cryolite is used in this electrolysis. Well, of course, the first one is that the cryolite dissolves the aluminium oxide and increases its conductivity. Also, it lowers the operating temperature and thus lowers cost or increases profit. It's better to say lowers cost though. Okay, the anode is made from carbon. Explain why the carbon anode has to be replaced regularly. Well, of course, when we're making oxygen, at the anode, then the oxygen is made at the anode. And of course, when we make oxygen at the anode, it's going to react with the carbon to make carbon dioxide. Hydrogen oxygen fuel cells can be used to produce electricity in vehicles. Write the symbol equation for the overall reaction in a hydrogen oxygen fuel cell. So it's asked us for a symbol equation, so we must write the symbol equation. And of course, it is hydrogen gas reacting with oxygen to make water. Now, all we need to do is balance that. We've got 2 oxygens here, so we must have 2 oxygens here. And now we've got 4 hydrogens here, so we must add a 2 here to make 4 hydrogens here, and then we're balanced. State 1 advantages of using hydrogen oxygen fuel cells instead of petrol in vehicle engines. Well, there is many, but the most obvious one is there is no CO2 released into the atmosphere to cause global warming. So it's much better for the planet.